Hello everyone and welcome back to MacTech 40, and today we will see one question of mechanical vibration, and the question has been asked in UPSC Engineering Service 2020, and this question is very good, and the similar kind of question that has been asked in GATE as well as BERC exam, and this question has weightage of 12 marks. Why 12 marks? You will get the idea at the end of this video. Okay, so first let me read out the data. A rotor has a mass of 10 kg. Okay, so here I am writing the given data simultaneously, that the rotor mass is 10 kg. Okay, and it is mounted on a midway on a 20 mm diameter horizontal shaft supported by ends of two bearings. So that means it is a single rotor system. Okay, so this is like a shaft, and there is a one rotor placed over here, and this shaft is supported by bearings at the two end like this. Okay, and the weight of this rotor is uh, 10 kg in 10 multiplied by gravitational acceleration 9.81, and the bearings are 1 meter apart. That means length is 1 meter, and here shaft diameter is also given, that is 20 mm shaft diameter. Okay, so the shaft diameter, that is 20 mm, so we will write in meter, that is 0.02 meter. Why is I'm writing all the units in meter? That is we will see in the static deflection calculation and natural frequency calculation. Okay, then the shaft is rotated 2000 rpm. Okay, so the rpm is given 2000 rpm. So now convert it into omega, natural frequency, sorry, not the running frequency, that is 2 pi n by 60. Okay, so you will get as a 209.44, 209.44 radian per second. Okay, and it is given that this shaft, so this rotor is eccentric, the center is slightly below, so that is some eccentricity here, and this eccentricity is distance is 0.11 mm. So I am writing here eccentricity small e, that is 0.11, 0.11 into 10 raised to minus 3 meter, and modulus of elasticity of material, that is 200 gigapascal. That means material is mild steel. Gigapascal 10 raised to 9 Newton per meter square. Okay, so now what we have to find, let us see. We have to find the amplitude of the steady state vibration. So we have to find amplitude. So for finding amplitude of the steady state vibration, we have to find the first natural frequency of the steady state. Okay, so as you can see here, this is a case of simply supported beam. Okay, and the steady state amplitude, so in steady state the deflection is due to the by weight. So the weight is the, and it is called static deflection. So the static deflection delta S. In case of simply supported beam, we have studied in strength of material, that is WL cube upon 48 EI. Okay, so W is the weight, that is 10 into 9.81, and L is 1 meter, so 1 cube 1 divided by 48 E, that is 200 into 10 raised to 9 multiply by the I that is moment of inertia. So moment of inertia I we can find by pi by 64 into d power 4. So here pi by 64 into d power 4, that means 0.02 whole power 4. So here you will get the deflection, the static deflection. Here the static deflection is, you can get 1.30 into 10 raised to minus 3 meter. Okay, why I'm writing in meter deflection, or simply I can write 1.3 mm. But when, as per the Rayleigh's method, because in case of the beam and the deflection, that is in transverse direction, the amplitude of the vibration in transverse direction, because the unbalanced force is acting perpendicular to the axis of the shaft. Okay, so the amplitude of the vibration will be in transverse direction. If this is rotating in this direction like this, omega, so the amplitude will be in transverse direction. Okay, so here we will use Rayleigh's method. So in Rayleigh's method, we can find the natural frequency. We have the one formula, like natural frequency is equal to G by static deflection. So here G value we are generally taking 9.81, but the unit is meter per second square. So here in exam, if you take the deflection in mm, so you might be in a trouble, because your natural frequency value will get somewhat higher. Okay, sorry, lower, and your final answer is not the same as the correct answer. So here you have to take 1.30 into 10 raised to minus 3. So you will get, when you solve this, you will get 86.83 radian per second. Okay, so this is your natural frequency. And now amplitude, steady state amplitude is given by, the equation is steady state amplitude eccentricity divided by omega n by omega whole square minus 1. So eccentricity is what? 0.11 mm. So I am writing here in meter, 0.11 10 raised to minus 3, and here omega n is what? 86.83, and the rotation, the at which rpm it is rotating, and this natural frequency, that frequency, running frequency is 209.44. so here I am writing 209.44 whole square minus 1. Okay, so when you solve this, you will get minus 1.3 into 10 raised to minus 4 meter. But if you write in mm finally, so you will get minus 0.13 mm. Now this is the answer, this is the final answer. But if you solve till here only, then you will definitely lose your marks. Why? Because the amplitude minus 0.13 mm, it will give you only 6 or 7 marks out of 12 marks. Okay, why? Because the amplitude, that is of some magnitude, and it is in negative direction, negative value came. So why negative value came, you have to justify this. So the justification you have to write in the exam, that is, the amplitude is in negative direction indicates that the rpm at which our shaft is rotating here, this rpm, omega, is very much greater than omega n. That means it is rotating at beyond the natural frequency speed. So that's why the amplitude, negative amplitude, indicates that the deflection of bending will be in opposite direction. Here here the deflection eccentricity is 0.11 mm below the center axis. So generally in our mind, what will be the deflection look like this? Okay, the deflection will be like this. But in this case, when the shaft is rotating and it crosses the natural frequency, So the deflection will be here, in our case it will be like this, in upward direction. So that's why it is come negative. So this amplitude of this vibration, this is a 0.13 mm, but it is in upward direction, so we have taken as a negative. Sorry, the negative value came, so that indicate that this is in opposite direction. So this is the significance, and this is the way you have to write, so you will get the full marks. Okay, hope you guys clear this, and tomorrow we will meet with some new questions. Till then, keep studying, stay focused, and stay safe.